Thank you. Thank you. All right, so it's a 30-minute talk, lightning talk, so we're going to do this lightning fast. So my name is Mark Baggett. I'm an instructor for SANS. I'm the author of a couple of different SANS courses, 573, which is Automating Information Security with Python, 673, which is Advanced 573, and then I'm the co-author of a course that's going to be coming out sometime next year on an introduction to Linux security. I'm going to show you some of that. One thing that kind of think is kind of cool is my name appears in the source code for Metasploit 7 times, even though I've never written a module for Metasploit. Just other people have written plugins and things for TTPs and things that I've developed, and then given me credit for it in the source code, because the information security community is awesome in that way. So what I wanted to talk to you today about, actually, I came up because of this tweet, right? So somebody tweeted on the internet, "I'd like to thank whoever decided it was cool to shove secrets and passwords and tokens and stuff into environment variables and make attacking stuff so much easier." And the truth is that, particularly as we move to the cloud, right, we're getting more and more stuff put into environment variables, right? Here's, AWS, you're setting your access keys, secret keys. This is some code from Django, a Python web framework. And just look at some of all of this OS environ get is it pulling environment variables. And it's looking for API secrets and debug mode and allowed hosts and the app database, the database engine and the database name and the database username and the database password and the database, right? Lots and lots of information that's stored in environment variables that if attackers can get to that, it's really useful. And so I was doing some research, working on some stuff, and I saw that tweet that was out there. I just saw up there, showed you a minute ago. Whoever to do that, and I posted a question on Twitter. I'm like, yeah, that's cool, but how are you getting these environment variables? Because, well, the scenario I was looking at, it was actually kind of difficult to get to some of the environment variables. And of course, the obvious answer from everyone on Twitter is, you type set, or you type env mark. What's your problem? How do you not know how to get environment variables? So this entire presentation is actually just my response to that and trying to say, no, I'm not really just an idiot. There is these circumstances where environment variables aren't that easily accessible. And let's take a look at some of those. And then we can decide if I'm going to redeem myself here. So I'm going to start out with this with a bit of a demo. I'm actually demoing something that comes from one of the new courses I mentioned, which is the 406 class. And so this is actually going to be one of the labs that is in 406 where we talk about, oh, that's not it, where we talk about environment variables. Did it go away again? How did it go away again? Okay. Unplug, there we go. All right, environment variables. Can I go full screen? It stayed. Look at that. How about that? All right. All right. So I should have done this ahead of time. So kind of the idea with 406, which is the introduction to Linux, is we really love to have a class where we don't need an instructor, that we can just turn you loose on hands-on labs and let you learn through experimentation and doing things. So you'll see at the bottom, I'm getting these prompts asking me to do certain things. I'm kind of skip forward to what it is that I wanted to show you. And as much as I can, I'll make everything as CTF, right? So, hey, echo and display the variable name used to store your path to your home directory. So what variable am I looking for here? $home, okay? It's an introduction to Linux, okay? Let's see, what's next? Variable that contains the list of directories that Linux searches through for commands you are trying to run. Echo $path. All right. And then I think next is what I really wanted to get to. OK, so let's go ahead and create some variables here. I'm going to go ahead and create the variable myvar, M-I-V-A-R equals 10. All right, and this creates that environment variable. And now to retrieve that environment variable, I can echo $myvar. and it will show me the contents of the variable that I just created. So now it's going to tell me, hey, there's a couple of different ways you can view environment variables that you've already got created. I can type env is one of those ways, and this displays, well, the environment variables that are exported. It tells me it's hard to find. Let's grep for it. So let's type that and type grep my var. All right, and there I can see that my var does not appear in env. So just creating an environment variable, it doesn't appear in env. Now where it does appear is what it's going to have us look at next, and that's if we type set. Right, so if we change that to set, I can see, all right, my var is shown there. So the difference between the two is whether or not the variable is exported. So when you export a variable, an environment variable, that allows sub-processes to see those environment variables. And right now I don't have this thing set. So what is it going to tell me to do? So this is going to tell me to open up a new shell. So bash, and then when I get in there, try and echo my var. And you'll see that in this sub-process, right, the sub-process doesn't have access to that environment variable. And I can check env with that grep command again, and it's not there. But if I go back to my parent shell, and then I export my var, then magically now everything should be able to see that. So now if I look at env, I can see that the variable does show up in env, and if I go into another sub-process, such as bash, I can now echo $myvar, okay, and it appears there. Okay, so you have to export the variables for child processes to see those types of variables. Okay, so local variable, unexported versus exported. Okay, and I just demoed these 3 slides. So when a variable is not exported, it can only be seen by, well, if you open up a bash prompt and you set an environment variable, you can see it in that bash prompt, right? None of the child processes can see it. But when it's exported, all the child processes can see it, and the process can itself. So how does this affect different exploitation scenarios? So let's look at the first scenario, which is the one that everybody on Twitter was talking about, which is where I've created all these environment variables, and then my web server is accessing them and then makes them, well, they're in memory inside of my web server. So to demo this, I'm going to come over here. I'm going to use a web server. I got a tool that I've written called APIify, which, actually, let me first do this. Let me create an environment variable. So I'm going to create a variable called Cloud API Secrets, and I'm going to export it, and then I'm going to start my web server called APIify. Now, this has got a code injection vulnerability in it, but it's actually a configuration option. You can say, do you want to be vulnerable to code injection or not? And I've chosen to say, yes, I do want to be vulnerable to code injection. So with this one, what it's going to do is actually run ping. It's going to run this command right here, plus whatever command line argument I pass to it on the thing. And the idea of APIify is I just want to JSONify the entire world. So if you have any Linux command that you would like to be able to integrate into some type of an event management platform, right? You can just run this, and it'll cache the entries, and it does about 60,000 requests a second, is what we saw, something like that. It's pretty fast. Okay, so because I've enabled command line injection, I can do things like this. I can ask it to ping google.com, and then, well, also semicolon student, or who am I? So I've got a code injection vulnerability. And with that, I can put whatever command I want to after this semicolon. So I can do things like, hey, let's echo $, what was the variable that I created over here called? Cloud API Secrets. So let's echo, this is going to need to be a space here. So that's I'll put a %20 here. And then Cloud API Secrets, and no secret. Did I do? Yeah, there you go. And so there I've got my top secret data that I could see there. Now there's actually another variable in here that I want to come back to and just show you in a minute. Let me just show you that I can also get to this other variable that's here called more secret. Okay. Right, so this, and oh darn it, it's a spoiler alert. I created this one setting it after the process actually launches. Okay, so I can't, and actually you can run anything, right? I could just run set here if I wanted to and get back a list of well, all the environment variables through this command injection. Okay, so yes, if you have environment variables with sensitive data inside those, and those things are loaded in memory, and the web process has access to those environment variables, then if you've got a command injection vulnerability, they can pull all those things. If you've got Amazon keys, whatever, database names, passwords, if there's a command injection vulnerability, all right, bad things are going to happen. So what's the trick? Don't have command injection vulnerabilities, right? That's bad. But what about the scenario that I was actually talking about when I asked the foolish question of, well, how do you get these things out of the process memory? And that is, let's say that the attacker gets onto the web server, right? I've got my web server and all this stuff's loaded in memory, but I get in via either an exploit that's on the system or by guessing an SSH username or an FTP username, get on the systems where I've got shell running on the same system as, well, the web server. How do I get to the stuff that's in memory in that server? And it turns out that, well, it kind of depends, right? So some things that you can do to make it a little bit more difficult for attackers that are in that scenario where they're on the same system and I'm just trying to grab something that's stored in a service configuration or something is, well, you can make it so that the variables are only inside of the child process and not inside the parent process that launched it. So for example, you know, if you are at the command line, if you want to just set an environment variable inside of a child process but not have it be available in your own process, you can set the environment variable, just space, and then the other command you're going to run. Now, here I'm setting a variable called myvar2 equals blah, and then I run a bash prompt that's trying to echo myvar, and you can see that, oh, it does have access to it in that bash prompt. But here, back in the parent process, the thing that launched that child process, the variable is not there. So it was only available in the child process, not in the parent process. So that's one thing I could do. Of course, here, what's a great way to grab this thing if this is what I did in order to set that environment variable? The history command, right? I can just go into the history, right? So anything you type there is obviously going to show up in the history. Well, one thing you can do to make it so that your sensitive environment variables that you don't want everybody to have aren't recorded in history is by default on most systems, bash is configured so that if you just put a space before a command, that it's not going to be recorded in history. So space export API key, and now, well, it doesn't show up in my history. Of course, whether or not that works depends upon an environment variable, right? So you've got this environment variable called hisControl that says, hey, here's my options. Ignore space is one of the options. Ignore both is going to ignore both space and duplicates. So if it's this or this, then I can just use the space to not record my environment variables. All right, so let's say that we do all of those things. I'm on the same system as the web server. What's a great way to grab the information that's on there? Well, first place I went to is the proc folder, right, what we have on our Linux system, because when a process launches, the operating system does it. So let's try that. So over here, I've got my web server. Let's see. Let's figure out what my process ID number is. All right, so my APIFI is running here under process number 7681. So let's cd into proc/proc/7681. And in there, I'll have a folder called environs. Okay, and then in environs, I'm going to cat environs, ANVENVIR, and I'm going to just grep for API, or let's just grep for secret. Okay. Oh, grep -a secret. All right. And so there you can see my cloud API secret shows up there, right? But one thing didn't show up there, and that was, what was the other variable that I asked for here? It was more secret, right? More secret was available here when I used it through a command injection. I was actually able to see the value that was in the more secret. So here I can see that value there. But over here in proc environs, it's not there. Does anybody know why it's not there? because the kernel sets that at launch, right? The environment variables inside of proc are recorded when the process launches, which means that if in my scripts I set all my environment variables and then I launch my web server, those will show up in proc. But if the process was to set its own environment variables or to do other things to have its information stored, that's not going to be set in proc. So that's, well, maybe I could have my process create environment variables to have its configuration. So that gets into, well, maybe then I have to feed it a configuration. Well, actually, the point here is that actually configuration files, I think, are more secure from this standpoint than environment variables. But now your configuration files are also in clear text that are on the machine, so that now I'm just looking for configuration files to get that. So well, I'll get into some of that, but there you go. So my question was, okay, I'm in a situation where I actually want to get the keys that are in memory on this process that were set after the process launched. How can I do that? And this turned out to be, well, a fun afternoon of coding, because it turns out that, well, it's not as easy as you want. I did write a process, and this is on my, it's actually on a gist, right? gist.github.com/markbaggett. I wrote this little process called, well, dump environment variables that given a process ID, what was my process ID number? 7681. All right, so I can sudo process 7681. And what it's going to do is actually use GDB to hook the process, then go through the data structures that are in GDB, pull out all the environment variables. And so, yeah, I can still get to them, but, well, I have to be able to dump memory on this system. So I'm like, all right, awesome. I wrote this little program. I went to the system. I'm like, let's dump the memory. And it doesn't work. Wait a minute, why can't I dump the memory? It works on my system, right? That's what we say as developers when we write code. But it turns out I was actually the customer in this case who was trying to use the code on another system, so I had to figure it out. I couldn't just say it works on my system. So why did it work on my system and not on the other system? Well, it turns out that there's some Linux kernel configurations that can prevent this. And I don't know where I am in my slides now. All right, so demo it in proc, just did stealing variables. All right, yep, I did have time for that. So who can steal stuff from memory? Well, it actually depends. Root can steal anybody's stuff from memory. So if the attacker has root on your system, as we all can imagine, game over, right? They can get those, but they've got everything that they need at that point. But what about where I was, right? If I pop the account for the Apache process, the service account, and I'm on there as another Apache process, can I dump the memory from another Apache process? And the answer is, well, no. You can't in most circumstances. Actually, there's a setting in this config, ptrace config, which prevents you from dumping memory in other sibling processes. So if I was in an Apache web service account that was like the child process of the web server, then I could get to those things. But if I'm just on the system as another Apache process, then I actually can't dump the memory from those processes. And this is a memory dump. So this doesn't just apply to environment variables. This would apply to configuration or just any sensitive data that's kept in there. If you're a sibling process, then you cannot do this. So awesome. I'm just going to go in there and I'm going to change the setting inside of ptrace. And who can change that? Root, right? Root. And it's going to require a reboot of the system afterwards. So this is actually kept me out from getting those environment variables. So there's that. Okay. So the answer is just stick everything into config files, right? Yeah, except people put config files on their system and then they forget about them and they post them to GitHub, right? So here, go to Google, DB user, file type env. These env extensions are where people set environment variables in all kinds of frameworks, and then it loads those things up into memory. So Yeah, so these don't look like templates. These look like legit usernames and passwords that are coming back to me. Okay. So there's that. The other thing I wanted to mention about environment variables is environment variables are also really useful to an attacker from an offensive standpoint. I don't know if you've been looking at some of the interesting backdoors that have been developed over the last year or two, but there's this thing called the symbiote backdoor in Linux, and it's actually using this environment variable called LD preload, right? Where by default, Linux processes they can either load system libraries on their own, or if they're configured to, they can just use the libraries from their parents. And actually, the default is to if my parent process already has this library loaded, then I'm not going to load it up myself, right? I'm just going to use the one that my parent process did. But you can change that, and you can say, hey, even if your parent process has it, then I want you to load it, and by the way, here's a path for that file. So you can, it's basically like DLL side loading on Linux, or on Windows, but it's roughly the Linux equivalent of that. So there's some privilege escalation exploits, and here I've got some links that you can go back and watch the slides and pull out these links, but there's some cool privilege escalation exploits that you can use with LD preloading, and there's some backdoors that have some interesting. And here's another fun one. This one is kind of fun. I thought I'd just show this to you here. How about an environment variable that creates a keylogger? So let me see. I think I have on my desktop the ability to demonstrate this to you. Let's see. ls. Yeah, let's cat env keylogger here. So, and then I'm going to, over here on this window, I'm going to put a little while loop. It's going to be a Netcat Listener. Okay, so let's just do that here. So this is going to be my attacker here on the internet. This is my attacker, paste. All right, so he's got his little Netcat Listener running over here. And then here on my victim, I'm just going to set the prompt command environment variable. So what does the prompt command do? Well, the prompt command is going to run every time a prompt appears. And what am I telling my prompt command to do here? I'm going to say, all right, anytime you make the prompt appear, I want you to run the command history-a, which says take any command history that you've got in memory and commit it to the file that's on the system. Then I'm going to say, all right, now take the last line out of that file, the bash history on that system, and then just write it to /dev TCP, the IP address of the attacker, port 9000, where I've got my little Netcat Listener running. So here, by just creating this environment variable, now if I type ls id, who am I? Who am I? Right, back over here in attacker land, right? It's a keylogger, right? We're not getting the output, but it's a keylogger, not an output logger, right? So with just an environment variable, right, we can do things like creating it in environment variables. And since we also talked about dumping memory, I thought this would be a good opportunity to just throw out this other thing I tweeted about, which was, is anybody not using GitHub these days? It's another thing that, cloud use has exploded. Everybody's using GitHub to configuration. Anybody using Git credentials to just, you know what, I'm tired of typing that password all the time? Yeah. So if an attacker can dump your memory, and a good process to dump memory is, if you're root, of course, is gcore, where you can just say, hey, record in this file all of the memory from this process ID. And then you just run strings on it. So here I'm just going through that memory dump and looking for user / or password. And here you can see my username or password there. So this is another thing relating back to what we taught. Who can dump that memory? Well, root. Don't let people get root on your system. And parent processes of the same user ID. And that's who can dump that memory. And that is what I've got for you in 30. We got 5 minutes left. So I can take questions. My points here are these. There's a lot of sensitive data in your environment variables. Don't put stuff there that you really care about, and do what you can to lock your systems down. There are some things you can do, like make sure it's not in your history and things like that. If possible, have all of that sensitive data load into memory afterwards. Then it won't be recorded in proc. And then it's just a matter of protecting memory through good privilege, through good rights management. Okay? Any questions? Because I'm standing between you and lunch. What you got? Could I use ptrace to defend against that and ptrace myself? I don't know. I don't know. I'd have to experiment with that. So I'm not quite sure. But that's a great question. Would you like the red team field manual, or would you like a war collar? War collar? Okay. Here's a broken war collar, unless Charlie catches it. Okay. Question? I don't have the slides for download, but they'll be out on a YouTube. There'll be a YouTube video on it. Yep. Other questions? What you got?
This is more distro specific, but on the child process, where you can kind of scrape on the side, would SE Linux protect against that?
Would SE Linux protect against a sibling process, even a sibling process doing it? There are so many management and configuration changes that are in SE Linux. I imagine that there's probably something that you could use to protect against that with SE Linux, but I can't give you a definitive answer on that. But with that, maybe the answer to your question is in the red team field manual. And so there you go. All right, so for lunch, you should have blue tickets, right?